afternoon, or good evening, wherever you are. Thank you so much for joining us in this Meet the Expert webinar. I know that is an interesting field. We also want to say thank you to Sam, the director of the EACA, to be here with us. And of course, Vlad, thank you so much for accepting our invitation. We know that your knowledge and the information that you will share today with our community and with our students will be so grateful for all of us. So before to start with our Meet the Expert webinar, I would like to mention that this one is a series of webinars that we organize to have the opportunities to get new knowledge for our students, our community, to be connected, to have new experience in the field. I would like also to mention some information about European Forensic Institute. We are really close to start our bachelor programs in October and our masters in November. So if you are interested in some information about our programs, for sure, you can receive the information, you can write us, you can follow us. We offer the Bachelor in Forensic Science or the Bachelor in Criminology. Also, these programs we offer in English or also in Italian. For our masters, we have the Master in Biology, the Master in Criminology, Master in Business Management, and of course, the Master in Cybersecurity. That is one of the informations that today Vlad will share with us. So I would like to give you the floor to Sam to start with our webinar. Please, if you have some questions, you can put in the Q&A section, and in the end of the webinar, we will reply.
Thank you so much, Norma, for the first words. A warm welcome to Vlad. It's so great to have you here. It's a real honor. Maybe most of our attendees already know that, but Vlad is the Analyst of the Year 2024, and he was awarded by EUROPOL, which in my opinion is a really great honor. And there, right now, as I know, there is no one for the year 2025. Maybe you win it once again after EUROPOL sees your great presentation. So once again, Vlad, thank you for coming, for showing us information about your experience, and the floor is yours.
Thank you very much. Thank you for having me, for inviting me here. I'm a bit nervous because of your kind words. Thank you again, and maybe we will see each other at CrimaCon 2025. Okay, I will share my screen right now. Okay, and if you please confirm that you are seeing the presentation.
Yes.
Okay, great. Okay, so guys, I have a little presentation and also a hands-on exercise about identifying breaches of protection orders. The exercise will be done with the help of ArcGIS Pro. Okay, so let's start some topics. Quick info on protection orders. A few technical details regarding interpreting call detail records. Some things about mobile phone towers and antennas, and also practical use of ArcGIS Pro. So a few things about me. Yes, as you said, I had the honor to be awarded by EUROPOL. I have 15 years of experience in law enforcement. I graduated the Police Academy in 2010, And I talk about intelligence analysis tools like Analyst Notebook, Maltigo, Tangles, of course. Nowadays, large language models like everybody. Yeah, okay. Moving on, some information regarding protection orders or restraining orders are legal directives issued by courts to prevent an aggressor from contacting or approaching a victim. For example, with the help of the analysis of mobile call detail records, we can get a few insights regarding cases which are involving stalking, domestic violence, or harassment. How CDRs support protection order enforcement? Basically, the keyword here is they are giving us clues, positional clues, for example, because I don't know if you are aware of this, but CDRs logs the time and location of the cell tower. Okay, so not the location of the device, the time and location of the cell tower, which is picking our call, for example, our mobile session. So if both victim and offender's device show connections to cell towers located in close spatial and also, of course, temporal proximity, this may indicate, and I want to emphasize this word, may indicate a breach of a protection order. So we don't know it for sure. Few things regarding how those call detail records are looking. We have some columns, like you see it here. We have the target number, the second number, the direction of the call, which can be incoming or outgoing based on the target. Date, time of the call, the duration, which is in seconds. We have the few details regarding the email of the target, some details regarding the ownership of that particular phone number, the IMSI, and also we have some details regarding the cell tower, like the latitude, the longitude, the cell ID, the cell location area code, which is basically a code for a specific area, like in Romania, an area of a county, for example. Also, we can get some details regarding cell direction or orientation. And this orientation is calculated in degrees, and we have the cell radius, which is kind of the coverage, but you will see those details later. Okay. I forgot to tell you, if you have something to add or some question, either you can do it in the comments section. Although I was introduced as an expert, I don't know that much. So if you consider you have to correct me, yeah, please be my guest. Okay. Some things regarding the email. The email of the mobile phone is that particular code, you can see it on the box. When you are buying a phone, for example, you have a long code, which is composed of 15 numbers, 15 digits. And from those digits, the first 8 digits are representing indicates the phone model, like we see in the presentation. After that, the 6 digits are the serial number, and the last digit is a check digit. Okay. For example, if you in my investigations, I'm seeing a lot of emails, of course, and if I want to know the brand of that particular mobile phone, I'm using this website a lot, email.info. It's quite accurate to check the email. And for example, if you want to check a particular email, and it will give you a message like the wrong check digit, you have another option within that within this particular site, email calculator. You can insert the first 14 digits like you see in the presentation, and it will give you the last digit. And with that, those 15 correctly calculated digits, you can insert in that particular website, and you will get the brand of the phone, which in some cases can be super useful. Maybe it was stolen, for example, and if you can cross-check this with your detective or your investigator, if you are from the law enforcement area, it will be great. Moving on to the IMSI. So this IMSI has also 15 digits. It is the short name for the International Mobile Subscriber Identity, which I don't know, think of it like a personal identification number. Okay, and those digits are used to identify the SIM card in the network. Okay. A few things about mobile cell towers or BTS data. So usually telephone records contain coordinates of cell sites of base transceiver stations that receive or transmit the data from mobile phones which are placed in the coverage area. Okay, so basically that particular BTS or relay, for example, that particular BTS is covering a certain area. So he cannot get a call which is placed from outside of his area. In some cases, for example, the phone records only contain the address of the BTS, meaning that you have to do some geocoding or reverse geocoding, for example. And this reverse geocoding can be done for free, in general, by using OpenStreetMap's free service, or also some paid service if you have access to it. Regarding the cell size of the BTS, a BTS, like I said, covers a special area known as a sector. And you can see here in this pictures we have some cells or sectors, and sector coverage depends on antenna location, the direction of the antenna, which is called azimuth, the beam width, and the transmission power, which is called the radius. You will see later on during the exercise. For example, the azimuth, like you see in the picture, is the horizontal pointing direction of a cell's sector's antenna. It is measured in degrees, and if you see this red line here, this is for example, if you can imagine, this is a particular direction of one antenna which has an azimuth of about 45 degrees. Okay, so this is the orientation of that particular. This is the the area which is covered by that particular antenna. Moving on to radius, it is often called a sector range or cell range. And like we see in this picture here, for example, the color red in here, it shows us that this particular antenna has a small radius. And if you see this green color there, it shows us that, this particular cell covers a greater area, for example. In CDRs, the radius is represented in meters in Romania, for example. But like I said in the presentation, it's not a hard boundary because it depends on terrain, clutter, power, frequency, and of course load. Load meaning the number of users connected to that particular cell. For example, on Christmas, there's a lot of people connected to those particular cells at 12 for the New Year. Sorry, for the New Year, a lot of users are connected at 12 a.m. to those particular cell sites in order for wishings and all kinds of stuff. Okay, moving on. Regarding the beam width defines the angular spread of the sector wedge. As you can see in this picture here, this spread is about 120 degrees, which is more or less the same data which we are having in Romania also. Okay, so enough with the presentation. I will do the hands-on. We will do the exercise. So here I opened my ArcGIS Pro. So now what you are seeing is my ArcGIS Pro project. It is called my project 21. I will go slowly. For example, I have here two Excel files. I don't know if you can see them. I have some telecom CDRs from the aggressor. and it's looking like this. So we have target number 2, direction of the call. Of course, it's all dummy data created by our wonderful robot friend or LLM friend. Okay, date and time of the call duration. Okay, the target cell phone, email, target first name, last name, the IMSI, okay, regarding that particular telephone number, and some details regarding the cell, cell latitude, longitude, the cell ID, the cell location area code, as I told you in the presentation, azimuth, and radius. Okay, so this is more or less what CDRs are looking. Yeah, if for example you have my telephone number, and for example number 2 represents the other participants of calls. Okay, so I don't want to save that. So I have this CDR regarding the aggressor and one CDR regarding the victim, which is kind of the same. The problem I faced, for example, is if the number of the telephone number of the victim comes from one mobile operator, one mobile phone company, and for example, the aggressor's telephone number comes from another mobile phone company. Those two companies don't share the location of the location of the cell phone tower. Okay, so they have in cities you can see towers everywhere. Well, those towers are belonging to a particular telephone company, right? So, for example, you cannot see on one regular phone towers two antennas, one antenna from a mobile phone company and one antenna from another mobile phone company. So that was the problem, because those towers were near to each other by and they had different addresses, right? So when I tried to analyze this data in Excel, I found out that the address didn't match. So that's why I had to use this space-time option here in ArcGIS, and you will see how. So first thing to do, let me bring my magnifier tool. Maybe you want to see a bit clear. So first thing to do is I will go in the catalog option from ArcGIS. I will click on computer because I want to add those Excel files in this layout. I have some folders here, and I will choose folder number 5. And in this folder number 5, I have this aggressor and victim data. You can see here this little triangle. I have to click on that particular triangle in order for ArcGIS to read my data. And you can see here this is the name of the sheet. I will just drag and drop to the map in order to bring this data here. And the same I will do for the victim. So I will click on this triangle regarding the victim, and I will drag and drop this victim underline CDR data here. Right now, you cannot see something. because they are just regular spreadsheets. So if you want to see something, some dots on the map, I will do the following. I will right-click on the aggressor CDR, and I will choose this option here, create points from table, and I will choose XY table to point. Okay. So in order to represent the locations of the cell towers, I have to use this option here, XY table to point. Input table will be the sheet. The output feature class will have this this name, but I prefer to delete the last things. Okay, and automatically here you can see on the X field and on the Y field, ArcGIS read my data and automatically fill those fields in here. But as a general rule, on the X field, you always have to put the longitude, and regarding the Y field, you always have to put the latitude. The coordinate system is chosen automatically based on your data here. So, for example, if your latitude and longitude has a different coordinate system, you have to select another coordinate system by clicking this globe here. Okay, I will press OK, and as you can see, some dots appeared on the map. Okay, so those dots are from all over the country. It represents the position of the mobile towers that which picked, so to say, which picked my my call with somebody else. Okay, so if we try to zoom in a bit, for example, and we try to click on a particular dot, here you can see the target number, a section of the call of the calls. Yeah, so you can see the target number, the number two, the direction of the call, date and time, and so on. Okay, so this is the aggressor here. Good. We'll do the same for the victim also, in order to geolocate the points to the map also for the victim. So I will right click on the victim, create points from table, and I'll choose XY table to point. So I'm doing a little rename here, and that's all. I'll press OK, and here you can see other points near to the aggressor. So you, for example, right here you can see that those green points are belonging to the victim, and the purple points or something like that are belonging to the aggressor. Okay, my ArcGIS is not quite slow, but a bit slow. So because I want to emphasize those points better in order for you to see. So I just have to click on the left side here. I have to click on that particular point, and I will choose, for example, a triangle for the victim. I will click on the aggressor also, and I will click and I will select the red circle. Okay, so I think now you can see better. that this point here is belonging to the aggressor and this point here is belonging to the victim. It's not belonging to the victim per se, because as I said, those points are the locations of the cell towers. Okay, so my target, for example, and the victim are around here, and you will see later on where. Okay, good. Next, in order to use, for example, this particular option, in order to select from all, you can see I have here 4,000 points, more or less. So from those points, I want to select the points which are near to each other, like, for example, within a range of 200 meters, and the calls should be placed on a time frame not exceeding 10 minutes. Okay, so I have to be very, very strict about that. Good. So in order for this to happen, ArcGIS has to make sure that our data has a date and time, because we have location, right? Location is latitude and longitude, but ArcGIS doesn't know if our data has some time, some date and time fields. So I will double click on the victim layer in order to be accessing the properties. And it's simple. I will go here. Here you can see layer properties, and I will click on time here, and I will check this button, filter layer content based on attribute values. Okay, so I will click on that. And regarding the time field, ArcGIS is already detecting the fact that this name of the field here contains the date and the time of the call. Okay, so here is this name here comes from the Excel file, right? Okay, so just I have to click here. ArcGIS automatically is detecting the date and time field from my Excel file, and I just have to press OK. Good. So the same thing I will do with the aggressor file, but my ArcGIS is performing a bit slow, so I have to wait a bit in order for you or for us to see a time bar right here on top. And after that, yes, I can see this time bar, and after that I'll do the same for the aggressor. I will double click on this particular layer. I will click on time, and I will click on filter layer content based on attribute values. I'll press OK. And regarding this, now ArcGIS knows that both of the layers are using date and time. Why is that important? Because in order to do some space-time queries, in ArcGIS, you have to have layers with date and time, of course, and with coordinates. Good. So after that, I will go here in my right side, in my top right, and here I have a button called geoprocessing here. So I will click on this geoprocessing option. If you cannot find the geoprocessing, it is very easy. You have wait a second. I think in the analysis, in the analysis menu, if you click on tools, if you click on tools, the geoprocessing tab will appear. Okay, so here we have a little search bar, and I will want to search for find space-time matches. Find space, yes, this is the option. So I will use this particular option to find space-time matches between the aggressor and the victim data. Okay, so I clicked on the find space-time matches. Regarding the input primary features, I will choose the aggressor data. Okay. Regarding the comparison features, I want to compare the aggressor data with the victim data. And this comparing stuff will be done by using space and time. So I will check this option, space and time. Okay, so regarding the search radius, regarding the location category, I will put 200 meters here. And regarding temporal search radius, I will search for calls which are taking, took in a range of 10 minutes. Okay, so I need to find some matching data between the aggressor and the victim. Okay, and this the location of the mobile phone tower, the location of those mobile phone towers have to be near each other, like in a range of 200 meters, and the calls which were received by the phone by the cell phone towers, sorry. Okay, the calls had to be done on a time frame of 10 minutes. Okay, so next, primary features, start date field. It's an easy one here because we only have this particular field, and regarding the comparison features, start date field is the same. Okay, good. And after that, I will press run in order for ArcGIS to calculate the space-time matches between the location of the cell towers, which were receiving the calls. Okay. So it's working. I will block this here. Okay, so what do we see in our left side? So we have the aggressor data, which is with red, victim data, and we have two more layers. 1 second, because it has to load. So we have two more layers. This layer here is for the aggressor prime match, and the first layer here is for the victim. I will, for example, if I want to see on the map only the victim match and the aggressor match, I will uncheck victim and aggressor CDR in order to see on the map only the things which I'm interested in. Okay, so this is how our map is looking right now. So those dots, for example, represent the locations where both the aggressor and victim were being positioned near to each other. Okay, so for example, regarding, I will do the same thing regarding the aggressor. For example, I will choose the red circle here in order for you to better understand. Okay, so on the red we have the aggressor here, and if I will click on that red dot, I will see that this call between the aggressor and another phone number occurred at 8th of May 2024 at 7:30 p.m., for example. Okay, and if I click on this circle here, which is representing the victim, the victim placed a call with this particular number on the same date like the aggressor, of course, and at 7:38. Okay, so this means that those cell towers, mobile cell towers, were near each other. Yeah. So, for example, if I want to measure the distance of those phone towers, I will click on Map, and I will click on this option Measure, in order to double check if this option find space-time matches did the performed good. Okay, so we have here a distance of 213 meters, more or less, because if I zoom in, I think yeah, the distance isn't that accurate when you zoom out. But those phone towers are in the right are in the right parameters, for example. So those two locations are in the right parameters, which are 200 meters between each other at most, and the calls to be placed on a 10 minutes boundary, for example. Okay, so we saw that those calls were placed at an 8-minute difference. Okay, but remember in my presentation that I told you that we have to establish also the cell site. Okay, so this is the location of the cell tower. These dots here are representing the location of the cell tower. But on each cell tower, some antennas are being placed. One antenna can be oriented to the north, one antenna can be oriented to the south. Okay, so we have to know in which direction the antennas are oriented. And in order for this to happen, I will choose another option. For example, I have a crime analysis add-on, which is great, but you can do it also with regular tools, which are built in ArcGIS. For example, I will utilize the cell site records to feature class in order to represent the sector lines and also the boundaries of those cell sites. And you will see how. So first, I will click on this option here. And first, I want to represent the coverage of the antennas regarding the aggressor's data. So regarding input cell site table, I will choose aggressor CDR prime match, okay, not just the regular aggressor CDR, okay. And that's the only thing I'll do here. After that, moving on, regarding the cell sector ID fields, I have to select, for example, which is my cell ID. So I have here the cell ID type. I will select cell ID, and regarding the my field from Excel, I have to have one field which is called, one second, sorry, cell ID here. So those fields are the fields from my Excel table. I will add another identifier, which is LAC ID, location area code ID. And from the field, I will choose cell LAC because I have this field available in Excel also. Okay, enough from here. Moving on to the X field and Y field, the app automatically chose the longitude and the latitude. Input coordinate system was automatically selected. Regarding the output projected coordinate system, I will choose current map, which means that the current map is in a projected coordinate system. You know, we have a geographic coordinate system, which is kind of the representation of the globe, and we have the projected coordinate system. If you imagine a map which is being laid on the desk, for example, this is a projected coordinate system. It's a 2D system. Okay, and the geographical coordinate system is in 3D, for example. Regarding the azimuth field, regarding the azimuth field here, we have it already in our Excel file, which is this cell direction and parentheses azimuth. Okay, moving on. We don't have a beam width field. In Romania, for example, more or less, the default beam width of the cells will be 120 degrees. In other countries can be 90, in other countries can be 60. In other countries, maybe they have the beam width for each call, but in my data, I don't have it. Regarding the radius, which is the coverage of the cell, I will choose cell radius in meters. Okay, so the last option here, take very good care of it because we have to choose the right radius unit. Okay, so this is about it. Yeah, after we fill all those fields, I will press run. It's creating the cell site records. Okay, so now I think you can see, for example, the aggressors CDR sectors here. Yeah, you can see the coverage of the cell and also the direction. Okay, the direction of the cell. And the same happens here also. Okay. For example, I will click on this symbol here to make it red in order to better differentiate. Okay, I don't know how much you can see, but this red antenna here is regarding the aggressor's cell. So basically, if we are looking at this particular cell, the mobile phone, which was used by the aggressor, can be placed around that pi wedge, for example, or around this in this particular area. We don't know for sure where, but we know at least that he was in this particular area at that particular date and time when he was placing that particular call. Okay. So moving on, I have to find out what is the coverage area of my victim's cell. So I will go to geoprocessing. I will search again for the space-time matches, but no, sorry for that. I already did that. I will go to the crime analysis tab, sorry, and I will choose cell site records to feature class again for the victim. And I'll do it quite quickly because we don't have already, we passed the allocated time. I don't know if you are here with me. Okay.
Yes, we are listening.
Okay, so I will choose victim CDR underscore comp match. Okay, so victim underline CDR underline comp match here. Same applies regarding the ID of the cell. I will choose first the cell ID. I will choose the cell ID from my Excel. And I will choose also the location area code ID. And this here, I have it like this. Moving on. Regarding the output projected coordinate system, I will choose current map again. Azimuth field, I will choose this cell direction. Regarding the beam width field, I don't have a beam width field, so I leave this field blank. I will only modify this 90 degrees to 120. Okay, this is the beam width of my cell, and regarding the radius, I will select cell radius, and radius units. I have it in meters. Okay, I will press run for the victim. And I cannot wait to see what happens. So this is a particular case right here. So for example, although the aggressor is positioned here and the victim is positioned there, it doesn't mean that those two were near to each other, or I don't know, those two were spying on each other or something else, right? So I cannot assume that they had a visual contact right here, okay? Because those coverage areas don't overlap, right? Instead, if we are looking at this case here, in this case, you can see the overlapping. So both the aggressor and the victim could be positioned in the overlapping area. Could be, okay? Good. So now I want, for example, I'm interested only in those overlappings, right? I'm not interested in in those situations. So although the mobile cell towers are next to each other, the antennas are were directed in other places. So there is no guarantee that the target and the victim saw each other. Okay, so I'm only interested in the overlapping zones. Okay, so this is one this is how it looks at national level. If you want to zoom in here, for example, okay, this is the same situation. We have some overlappings there. Okay, so this CDR geospatial analysis is based on assuming stuff, right? It's not an exact science. Okay, so from all of this data, I'm interested to show on the map only overlapping data. So I have to do a basic intersect. So I have to intersect those two areas to see what is the common area. So in order for this to happen, I will go to the geoprocessing tab again, and I will write intersect. Okay, so I will write intersect here, and I think the first option is quite good. I will click on it. If you see this kind of a message, the pairwise intersect tool provides enhanced functionality or performance. My advice is to click on this particular tool because is the same tool, is the same intersect tool, but it is updated. Okay, good. So regarding the input features, first thing I will have to, but I'll have to see how my layers are named. So I'm interested in those two layers here. Aggressor, prime, match, underline, sectors. Yeah, so sectors are those lines here. Okay, those dashed lines. Okay, so I'm interested on intersecting those two areas here. Okay, so going to the pairwise intersect, input features, aggressor, prime, match, sectors. This is the first one. And the second one will be victim, underline, sectors. Something with sectors anyway. Okay. The output feature class will be called aggressor CDR pairwise inter. I will press run. And let's see. Because it is done. Okay. The reason that I don't see that much is because I have all those layers shown in the map. So I will uncheck some of them. Okay, like this. So if you uncheck layers, those layers will not be visible to the map, but will remain here on your left. Okay, so I will uncheck everything except for the aggressor CDR pairwise inter. Okay, so now you can see, or I will put that aside. I will modify the styling. Okay. Let's go to a more crowded place. Okay, here in this particular area, the victim and the aggressor were supposedly were near to each other. And for example, if I left click on this particular area, the attributes for that particular area are shown. Okay, And here we have the target number and the number 2. So we have the session regarding the aggressor. So this is the session regarding the aggressor, which is this one here. Okay. And if we scroll down, we have the session regarding the victim also for additional details. So for example, on the 2nd of May 2024, at this particular hour, we can assume that at least they saw each other, or maybe they were in this particular same area. Okay, we have small areas here also. Okay, here like this, and also we have we can check the victims, not that, the victim and the aggressor position. Yeah, but this was an intersection, right? So okay, so this is right here. This bold line here is the result of an intersection between this cell and this particular cell. Okay, guys, so that's it for me. I hope it was interesting. Yeah, and I didn't bore you too much.
No, you never bore anyone. It was just the some minutes that we lost because of our technical issues, but then it was a really great presentation. And Vlad, there is the Q&A box. Can you open it? Is it available for you?
Yeah.
Would you mind to answer it directly, these questions?
Yeah. So Cosmin is asking if ArcGIS can be integrated with other police systems like case management or CCTV to provide actionable intelligence in real time. In real time, from what I've experienced, no. But there is the fact that ArcGIS can be integrated with Python gives you the ability to run a small script to do some refreshings regarding querying some SQL data sets from which you are extracting data. And I think it can be done also in real time, but with the script, with the help of the some Python scripts or some batch files, for example, to set some triggers. Okay, so the next question, this analysis seems to work great, but in reality, is this data really readily available? Also azimuth, beam, beam width, and etc. Yes, for example, I can speak from from our perspective. From the law enforcement in Romania, we have this data readily available. It is true that we have it in another source, like in another database, but this doesn't stop us to perform, I don't know, some VLOOKUP, for example, and to add this data here in the CDR. Regarding this this data, we have you can use, for example, some OSINT websites in order for you to query the data if you don't have access to it. Sites like Wiggle or one second, because I had it bookmarked. but you can Google for those data. I think nowadays also OpenStreetMap has access to those things.
We have another question, but I think this one is more for us. So, one of the participants is asking if they will receive the information via email. I'm not sure, Vlad, if you have some issues to share with them, maybe the presentation, or if it's okay for you.
Yeah, yes. I'm open for this, so no
Okay.
problem. Yeah.
So in this case, we will send you a thank you email with the information. Also, the recording will be available maybe next week on our channel in YouTube. So you can also check again this webinar and share. Also, I would like, we already replied some of the questions that some of them they have. Example, Taha was asking about our program, our master in cybersecurity. So please, if you have some questions about our programs, if you want to know something in more detail, please write us via email or of course in our website, Instagram, Facebook, if you have any questions. So also we will send in the thank you email, the information about Vlad, our guest expert. Really, for us, it's an honor to have you here. Thank you so much. It was really useful, the information that you shared with us. And of course, we use a lot this information. So, Sam, I'm not sure if you have something more to
Yes,
add. Also, so
yes.
sorry. Also, Sorina was saying that she needs to leave, but she was saying thank you to Effie and thank you to EACA. So really, thank you to you to be here with us to share these spaces for new knowledge and, of course, to share some information about the field.
Yes, really, also a great thank you from my side. It's always a pleasure to have experts here sharing their information with our students and also with our members. And I know exactly because I can count the clicks on videos when I share them. I know that people also love to see it a little bit later when they have maybe more time or just to get once again through the presentation, especially what Vlad was showing us about the different steps in ArcGIS. It might be helpful to see the video, then pause it, then try it, and then run
Practice,
it,
yes.
run it again. I love it. I want to add one sentence about the one question: if it can work in real time. Yeah, you're absolutely right, Vlad. But you also have the opportunity to publish special maps where you can put crime information in real time on that maps. But of course, it's not the same when you start calculating if two different groups are coming together. So this is not possible in real time without the help of Python scripts. Yes, you're absolutely right. Yes, Vlad, thank you once again. It was once again great to hear you talking about your experience in the field, and I hope we will see you again soon somewhere, maybe at Europol, maybe on one of our next webinars again with some other topics. Thank you so much, and the last word is for Norma again to close the session.
Okay, we are receiving some new thank you to Taha from Anastasia also. Taha, he is connecting from Vienna. Really, thank you so much for to be here with us. We are really pleasure to have you here. We are honored to have Vlad here. And of course, see you in the next Meet the Experts webinar. Good day for everyone. Bye
Bye
bye.
bye. Thank you so much.
Thank you.